The MVX architecture separates out the model of your system and equipment from where it gets the data to populate the model. This allows an MVX Object Server to be configured for multiple deployment options using the same maintained configuration. This example shows the deployment configuration for a single MVX object model. The example MVX Server deployment configuration has been set up to allow for operations, training, and simulation. Each of these deployments can be associated with multiple separate data sources. The multiple data sources allow disparate systems to be integrated. The multiple deployments allow the same object structure to be used for different purposes. 3D and other client programs can then connect to different Object Server instances based on the same core configuration to get access to different sets of object values, such as live values from existing HMI systems, a training system with training-oriented values and interactions, or an in-depth simulation with heavy calculations for testing new software systems. Once the system-wide deployment options have been configured, then every single value in the MVX configuration can be either left as a configured constant value or associated with one or more external data sources. If an MVX property value is linked to external data, the small button to the right of the editable value is highlighted. Clicking on this button allows the configuration specific to that single value to be defined. The exact form of the per point configuration will be data source dependent. For industry standard HMIs, this will be a tag name or a script referencing one or more tag names. Another example of a data source specific configuration is some form of cell or range reference when the external data is coming from an Excel spreadsheet. The architecture allows for an object structure to be defined as a skeleton which provides a consistent shape for your system. You can then add the muscle to this skeleton with per property or per object data source configuration for different deployment scenarios. This multiple deployment architecture has a bunch of advantages. It's designed up front so that the same object configuration can be used in different contexts, such as operations, training, and simulation. Within each deployment configuration, we can integrate multiple sources of data and types of data. It's all extensible using Microsoft .NET technologies, so either your developers or our developers can customize it to suit if needed. The MVX product range includes the following dev kit products: the visualization dev kit for client-side 3D graphics creation, the connector dev kit for server-side development if you want to customize the server-side. The MVX Object Server comes with a standard set of equipment objects which will expand over time. Currently, .NET developer skills are needed to define company-specific server-side objects, but we'll be moving the needle away from programmer to engineer over time as we develop the MVX product range. There's plenty of depth with respect to what a .NET developer gets when working with the server-side connector dev kit. There's a complete domain model-based framework called the Talk framework included as part of the connector dev kit. We've standardized on the ISA 95 hierarchy concepts to organize the top-level MVX objects. The diagram being shown is called a class diagram. It's fairly easy to read with just a few diagrammatic hints. The double arrows indicate a zero-to-many relationship. So an MVX enterprise is made up of zero-to-many sites. A site is made up of zero-to-many areas. An area can be made up of a number of work centers, where a work center could be a process cell, production unit, production line, or a storage zone, depending on the type of activity carried out in that work center, and so on. All of the work centers can be linked to other work centers where the results of production are either being accepted as input or provided as output to another work center. These relationships define the production flow within an enterprise area. Any piece of equipment can be viewed as being made up of zero-to-many components that are also pieces of equipment. This componentization only needs to be configured to the level that is useful for your particular scenario. The ISA 95 approach is to define a meta-model where the structure of a type of equipment is separately configured at runtime. We're taking a slightly different approach that leverages the Microsoft .NET Framework and is also more easily extensible using the role pattern. The role pattern allows a single piece of equipment to be configured as playing multiple roles within a system. The example shows the concept of a maintainable role. If a piece of equipment is maintainable, then it needs to have a maintenance object configured, which, for example, links the equipment to an external maintenance system via an identifier. The power of this role concept is that we can just keep adding roles and put whatever we need into the role objects to link them to external systems without changing the core MVX software. Another easy to understand equipment role is a documented role, which can be used to locate all the documentation associated with a particular piece of equipment in some external document store. We can then allow users to initiate the display of the documentation from within the 3D environment. MVX objects don't have to get their property values from external data sources. They can also be derived property values using programmed logic. The example shows how a superphosphate roll circuit's ready status is derived from the combination of whether the cyclone circulating fan is ready, the dust rotary valve is ready, the classifier is ready, and the circulating elevator is ready. This programmatic logic leverages knowledge of the relationships, which allows the same program code to apply to any roll circuit. This example highlights the benefits of having knowledge of the relationships between points available to your industrial automation software. Another good example of this is where an object is configured to be related to multiple other objects. In this example, the classifier is ready when all of its roll motors are ready, however many there are, and when all of its fine dust motors are ready, however many there are. Because we're leveraging knowledge of the relationships and links between industrial automation information, we can write code that applies to multiple scenarios. The alternative is repetition of code, which means more places where work is needed when change happens, or when fixes are made. MVX objects are made up of these types of property values. An object property value can also be an array of values. This is useful in modeling things like stockpiles, pits, laser scanners, which all have a block of values defining their state. However, the true power comes from the object relationships, such as one-to-one relationships, and object lists, where there's a one-to-many relationship. We're also working on integrated video and audio streams as first-class citizens in MVX object models. We've written a small app that illustrates the conceptual reduction in complexity by knowing the relationships between items of information. It shows the same number of individual points of information displayed as points or as individual MacroView entities. MacroView entities can be viewed as complex tags where multiple points are defined as a single tag using a type definition. We can also display the information as an object graph where the relationships between the information points are clear within the diagram. This is a much easier to understand representation of the information as it shows the relationships between the information items. This app is also an MVX Object Server, which shows that we can embed the technology in a variety of places. We're connecting up to the MetaServer. We're connecting up using the MetaServer Explorer to this MVX Object Server. The connection failure occurred because the Object Server wasn't running. Let's start the server by clicking the play button, and then we'll run the Explorer client program again. It connects and can see the object structure of this particular sample application. It doesn't have to take many equipment concepts to get to a high point count. This is the advantage of using relationships and links. It allows us to better organize the information in our minds. It matches the system knowledge to our knowledge. The use of the ISA 95 standard for the hierarchy of MVX objects results in a hierarchy being the default MVX object structure. However, object graphs are also really useful in many industrial automation scenarios. The diagram on the right shows a social network graph which illustrates people's real-world relationships. It's clearly not a simple hierarchy. This can be contrasted against a typical org chart in a company that is presented in a hierarchy. But the reality is that the relationships between the people in a company are much more complex than a hierarchy. The same applies to industrial automation information. Video monitoring provides a useful example of how object graphs are useful. The position of a camera is such that an arbitrary set of equipment is viewable by that camera based on the physical layout. Hence, it can be linked to multiple pieces of equipment in MVX. An MVX area could be configured with a bunch of cameras. Those cameras can then be configured as being associated via relationship links with all of the equipment that is viewable from that camera. This functionality then allows us to answer questions such as show me all of the camera views where I can see a particular conveyor or piece of equipment. We can do this because the MVX system has been configured with the relationships between the pieces of equipment, between the camera and the conveyors in this case. We have a bunch of deployment options for MVX software both on the visual client side and the data-oriented server side. They're all .NET based, and it shows the advancement of .NET technology over the last 7 to 8 years since it was initially introduced. We're particularly interested in the Android devices as it gets us access to powerful portable devices that aren't constrained by Apple's approach to software, for example. We believe MVX has huge potential in general, but in particular when training needs are included in the thinking. People's natural strengths in vision, pattern matching, and linking information plays into this. We believe MVX makes it easier for people to visualize scenarios, see the patterns in the data, and see the links between the information. All of this makes it easier for someone new to a site to ramp up. I've seen this before when taking a domain model approach when developing software. Because the concepts presented in the software match the concepts and links that end up in people's heads, it makes it far easier to impart information. Combine this with the 3D aspect and it helps the visual thinkers as well. So in summary, the 3D visualization aspect of MVX is great, but don't forget the beneath the surface benefits. We can better organize your data through links and relationships. We can build on your existing systems and data sources. Thanks for your time viewing this presentation. For more information on MVX and other products, check out the Sentient Computing website.